So the purpose of this video is to explain polynomial division. We know how to add, subtract, and multiply polynomials now, so we have to learn how to divide them. There are two different processes for polynomial division, one of which works all the time but is a little more labor intensive. That's the one we're going to talk about now. And one that is shorter but doesn't always apply in all situations. So the first way that we're going to learn that applies in all situations is polynomial long division. Now, in order to know how to do long division with polynomials, we have to remember how to do it with numbers. So I've written a problem over here to the left where I'm dividing 1849 by 11. So if you remember, you make the little division house, and the thing on top of the fraction, the numerator, which is also called the dividend, goes underneath the house. And the number on the bottom, the denominator, also called the divisor, goes outside the house. And long division is a four-step algorithm. You divide, and in this case, you would divide 11 into 1. You realize it can't go into that, so you go to the next number and say 11 goes into 18 how many times? And it goes into it once. That number goes on top of the little house. So we divide, and then the second step of the algorithm is to multiply. So that means we multiply the 1 by the 11, and that goes underneath. Then we subtract those two things. So we would do 18 minus 11, and that gives us 7, and then we bring down the next number. So bringing down the 4. And then we repeat the process. So an algorithm is a set of steps you can repeat over and over again to accomplish a goal. So 11 goes into 74 6 times. 6 times 11 is 66. 74 minus 66 is 8, and we bring down the 9. Then we see 11 goes into 89, 8 times. 8 times 11 is 88. 89 minus 88 is 1, and we don't have any more numbers to bring down. Now, when you learned this in like 4th grade or so, you had the option of adding a decimal and zeros, which we're not going to do here, or you had the option of writing an R for remainder and a 1, which we're also not going to do here. But the other thing you could do is write that remainder as a fractional part of a mixed number. So basically, my quotient here is 168, and then I can take that remainder, which is 1, and place it over the divisor, make it 168 and 1/11. Now, keep in mind when you write a mixed number, it's technically this 168 plus the 1 over 11, not times. It's one of those rare times in math when you write two numbers next to each other, it doesn't imply multiplication. So this is long division with numbers. It's divide, multiply, subtract, bring down. Do it until you get to the end. You have no more numbers to bring down. Take the remainder that you have, place it over the divisor, and add it to the quotient. So the process we're going to do over here with these polynomials is precisely the same with one modification. So I'm going to draw my division house. I'm going to place my dividend underneath the house, just like I did in the numbers. I'm going to place my divisor outside the house, like that. And now I'm going to begin the four-step process. So divide, multiply, subtract, bring down. The big difference with this is when we do the division, what you're going to be doing is dividing the first term of the dividend, that's the thing under the house, by the first term of the divisor. Now, there's a very specific reason we do that, and I'll point that out to you when we get there. So in this case, that means taking this x cubed that's right here and dividing it by the first term here, which is x. So x cubed divided by x is x squared, and that's what goes above the house, just like it did in the numbers. So at this point, the steps are going to be the same. We're going to multiply that thing on the top, that x squared, by this x plus 3. Now keep in mind you're multiplying it by x plus 3. So you're going to get two terms out of that because the x squared would have to be distributed. So if I write that out to the side over here, x squared times x plus 3, that would give me x cubed plus 3x squared. And that's what goes underneath. My next step would be to subtract. So keep in mind, if I put a minus there, it doesn't look like I'm subtracting both things. So I'm going to put a minus with parentheses around it, or you could distribute the negative if you'd like. And I get, when I subtract these things, x cubed minus x cubed, which is 0x cubed. By the way, that's why we divide first terms, because this first term here, when you subtract, should always go away when you're doing long division. If it doesn't, you've done something wrong. And then we have 5x squared minus 3x squared, which is 2x squared. And my next step is to bring down. So I'm going to bring down the next term and then repeat the process. So I divide first term by first term, and that would give me 2x. That's what goes on top of the house, positive 2x. I multiply that by the divisor, and that goes underneath. I subtract those things. So 2x squared minus 2x squared is 0, so that's blank, just like it always should be. And 3x minus 6x is negative 3x. And then I bring down the next term. And then I repeat the process again. So first term divided by first term. That goes on top of the house. Multiply that by the divisor. Write that underneath. Subtract. Negative 3x minus negative 3x is nothing. And negative 2 minus negative 9 is positive 7. Now I have nothing left to bring down. So that 7 that I have is my remainder. And just like we did with the numbers, we take that remainder and we add it to our quotient as a fraction. So I'm going to take my quotient, x squared plus 2x minus 3, and then I'm going to add a fraction that's made up of my remainder over my divisor. So this would be the answer to this long division problem. Now I'm going to make another video where the example is more complicated. So you'll see that in just a little bit. Okay, so this is a more complicated long division problem. So if you look at this problem, the main reason this is more complicated is that if you look at the top, we have x to the fourth, and then we have an x squared term. We don't have an x cubed term. When you have missing terms in polynomial long division problems, they can actually make life a little more complicated. So when I go to set this problem up, I'm going to make an adjustment to account for those missing terms. So I'll make my division like bar house thing, and I'm going to put my dividend underneath. So I have an x to the fourth, and then I don't have an x cubed term, so I'm going to put a placeholder in there. Since I have 0 x cubes, I'm actually going to put 0 x cubed in there. And then I have 3x squared, I do have an x term, and I do have a constant term. And on the outside, I'm going to put my divisor. I don't have any missing terms here. My highest degree term is 2, and then I have an x term, and then the 1. And then my process is going to proceed exactly as before. So x squared goes into x to the fourth, x squared times, that goes on top. I'm going to multiply that by the entire divisor, and that goes underneath. I'm going to subtract all of that. Again, first term to subtract away. 0x cubed minus x cubed is negative x cubed, and 3x squared minus negative x squared is 4x squared. Most common errors in the long division are just arithmetic errors, typically multiplication errors or problems with like signs, especially the subtracting step. So now I need to bring down my term. Now notice my divisor has 3 terms. I want what I have down here to have 3 terms as well. It has 2 right now, so I'm going to bring down 1 extra term. If I had only 1 term left away, like the first 2 things I subtracted, I would bring down only 1 term. So now, first term, change colors here, divided by first term. That's negative x, so that will go here. I multiply that by the entire divisor. Oops, should be a minus there. that goes underneath. By the way, inserting that 0 term, I don't know if you noticed it earlier, that made these x cubed terms line up. So when I went to subtract them, they worked out just fine. So now I'm going to subtract negative x cubed minus x. Negative x cubed is nothing. And then 4x squared minus negative x squared is 5x squared. And 2x minus x is x. Bring down one more term because I have 2 terms, I need 3. And so let's do this step here. First term, oops, wrong type of writing utensil, divided by first term. That would be 5. Put it up here as a positive 5. Multiply that by the entire divisor. That goes underneath. Subtract. By the way, I'm putting those boxes there. You don't really have to put them there. You can just leave it blank. I'm just sort of pointing out that it goes away every time. So this would be minus 4x, and negative 1 minus negative 5 is plus 4. Nothing else to bring down. So this time, I'm going to have a remainder of negative 4x plus 2. So when I write my answer, it's my quotient, x squared minus x plus 5, plus my remainder, negative 4x plus 4, all over my divisor, x squared plus x plus 1.